Hello students, I am Manoj Kundare, the Assistant Professor of Electronic Science. Welcome back to our e-learning platform. In previous video, we have seen the programs for time delays in timer mode 1 and timer mode 2. The link of the previous video is available in the description box. Please check it. Now, in this video, we are going to see the details about interrupts of 8051 microcontroller. We have already seen this point interrupt in the first chapter. Okay, let's see some additional details about the interrupts, like what is meant by interrupts, what are the sources of interrupts, and the interrupt registers IE and IP. Okay, let's start our today's topic, interrupt of 8051 microcontroller. We know that the 8051 microcontroller deals with the many devices which is connected externally, or it has inbuilt, or they are internally. That means the 8051 microcontroller has several input output devices, one serial communication port, then the timers 0, timer 1, etc. Okay, all these device needs service. Okay, hence a single microcontroller can serve several devices by two ways, polling and interrupts. Okay, that means the 8051 microcontroller can serve its device by using the two ways, polling and interrupts. First of all, we have to know the basic difference between polling and interrupts. Let's see what is meant by polling. The microcontroller continuously monitors the status of all the devices. Whenever any device needs the service, it provides the service and moves on to the next device until everyone is serviced. This will be done in infinite loop. That means here in polling, the microcontroller continuously monitors all the devices, and if any device requires service, then it provides service to it. After completing this service, the microcontroller goes to the second device and serves it. Okay, this process requires infinite loop. Hence the polling is not useful or not very used in the 8051 microcontroller. The next type is interrupts. Whenever any device needs its service, the device notifies the microcontroller by sending it an interrupt signal. Upon receiving an input interrupt signal, the microcontroller interrupts whatever is doing and serves the device. The program which is associated with the interrupt is called as the interrupt service routine or interrupt handler. That means the interrupt is the system or is a program in which the devices notifies itself to the microcontroller that it requires service. Then the microcontroller provides service to this device. Okay, that means in short we can say that, for example, if we want to transmit and the receive data. Okay, if we want to transmit and the receive data, then what happens during this transmission? If we use the polling type, then the microcontroller continuously monitor this transmission process. Okay, and after this transmission complete, then it receives data or it does its next task. But if interrupt system is used, then during the transmission of the data, the transmitter transmit data through the TI pin, and if the transmission is completed, then this pin generates an interrupt which notifies the microcontroller that the transmission is completed. This is the basic process done in the polling and the interrupt. That means in polling, microcontroller continuously monitors the status of the device, while in interrupt, the device itself notifies that it requires service. I hope you all understand the basic difference between the interrupt and polling. Okay, now let's see what is an interrupt. An interrupt is an external or internal event to get the CPU's attention. Once the controller detects the interrupt, it suspends or stops the current job and executes a special service routine known as interrupt service routine or ISR. That means Whenever the interrupt occurs, the interrupt may be external or internal. Then microcontroller stops its current execution and it executes the interrupt service routine to serve the interrupted device. Okay. Upon activation of an interrupt, the microcontroller goes through the following steps. The steps are, the first step is, if the interrupt is received, then microcontroller first finishes the instruction it is executing and saves the address of the next instruction on the stack. That means whenever the interrupt occurs, then the microcontroller finishes its executing instruction and saves the address of this instruction on the stack. The next step is, it also saves the current status of all interrupts internally. Then it jumps to a fixed location in the memory called the interrupt vector table that holds the address of the ISR, that means interrupt service routine. The microcontroller gets the address of the ISR from the interrupt vector table and jumps to it. That means whenever the interrupt occurs, the microcontroller finishes its instruction and saves its address into the stack. Then it jumps to the fixed memory location called the interrupt vector table, which holds the address of the ISR. Then it starts to execute the interrupt service subroutine until it reaches the last instruction of the subroutine, which is RETI, that means return from interrupt. Upon executing the RETI instruction, the microcontroller returns to the place where it was interrupted. That means, in short, we can say that when the interrupt occurs, then microcontroller saves its address into the PC. Then it executes the interrupt service routine, and after the completion of the interrupt service routine, it gets or it returns to the place where it was interrupted. Okay, that means the normal sequence of the program is executed. Then in this process, first it gets the program counter, that is PC address, from the stack by popping the top 2 bytes of the stack into the PC, then start to execute from that address. I hope you all now understand the steps for the interrupts. Now let's see the types of the interrupt. The 8051 microcontroller can recognize 5 different events or interrupts that cause the main program to interrupt from the normal execution. That means, in short, we can say that the 8051 microcontroller has 5 interrupts. Out of these 5 interrupts, the 2 are internal, the 2 are external, and one is serial interrupt, from which the internal interrupts are the timer interrupts and the external interrupts are the INT0 and INT1 interrupts, and one is a serial interrupt which is used for transmission and reception of the data. Okay, then the 5 sources of the interrupts are timer 0 overflow interrupts, that is TF0, timer 1 overflow interrupt, that is TF1, external hardware interrupt, that means INT0, external hardware interrupt INT1, and serial communication interrupt RITI. Okay, that means here we can see that there are total 5 interrupts, but there is one more interrupt in 8051 microcontroller which is called as the reset, and this interrupt has the highest priority interrupt. Okay, because whenever we press the reset button, the microcontroller stops its all the task and initiate or jumps to its initial address or the starting address. That means we have seen the details about the reset. That means after applying the reset pin, then the microcontroller stops its current job and jumps to the initial address 000H. Okay, I hope you all remember the function of the reset pin. The reset is also called as the interrupt of the 8051 microcontroller. That means the 8051 microcontroller has total 6 interrupts. 5 interrupts are TF0, TF1, INT0, INT1, RITI, and one interrupt is reset. Okay, I hope you all understand the types of the interrupt of 8051 microcontroller. Let's see the 8051 interrupt vector table. This is the address where the controller jumps after the interrupt to serve the interrupt service routine. That means whenever the interrupt occurs, then microcontroller jumps to the interrupt service routine vector table. Okay, that means it jumps to the vector table, and the interrupt occur, it jumps to this location, the location of that interrupt, and execute it. Okay, let's see the interrupt vector table or the ROM location for the interrupts. Okay, the first interrupt is reset, which is at the 000h location. The next interrupt is external hardware interrupt, that means INT0, its address is 0003h. The next interrupt is timer 0 interrupt, that means TF0 interrupt, whose address is 000BH. The next interrupt is external hardware interrupt 1, INT1, whose address is 0013H. Okay. The next interrupt is timer 1 interrupt, that is TF1, whose address is 001B. And the last interrupt is serial communication interrupt RI and TI, whose address is 0023 hexadecimal, that means H. This is the interrupt vector table. According to this, the which interrupt executed first is decided. That means if the two interrupts are occur simultaneously, that means if INT0 and the TF1, these two interrupts are occur at the same time, then the 8051 microcontroller executes first the INT0 interrupt and then TF1 interrupt, because INT0 interrupt has the highest priority interrupt. Okay, I hope you all understand these things. Now let's see the details about the interrupts. First one is reset. The reset is the highest priority interrupt. Upon reset, the 8051 microcontroller start executing code from 000 address. That means we already learned this function about the reset pin, that if the reset pin is pressed, then 8051 microcontroller stop all its current tasks and jumps to its initial or the starting address. Okay, I hope you all remember this. The next interrupt is internal interrupt, and these interrupts are also called as the timer interrupts. We know that 8051 microcontroller has two timers, T0 and T1, and both these timers are of 16 bit. Okay, these timers are used for the timing and the counting purpose. Whenever we use the timer, then the TF0 and the TF1 flag are used to represent the timer overflow condition or the timer overflow status. Whenever the timer overflows, then these flag sets, that means the interrupt occurs. I hope you all understand. Let's see. The 8051 microcontroller has two internal interrupts, namely timer 0 and timer 1. Whenever timer overflows, the timer overflow flags TF0 and TF1 are set. Then the microcontroller jumps to their vector addresses to serve the interrupt. For this, global and timer interrupts should be enabled. Okay. Then let's see the serial interrupt. We know that 8051 microcontroller has one serial interrupt, transmit and receive. Okay. The 8051 has serial communication port and have related signal serial interrupt flag TI/RI. When the last bit or stop bit of a byte is transmitted, the TI signal interrupt flag is set, and when the last bit or stop bit of the receiving data byte is received, then the RI flag is set. That means if the microcontroller transmits some data, Suppose the data is 01010101, then during this transmission this is the last byte, and if this last bit is transmitted, that means the total data is transmitted, then the TI flag set. And if the microcontroller receives the data on the RI pin, then after completion of this reception the RI flag sets, that means it gives the receive interrupt. Okay, I hope you all understand the interrupts here. There are the two external interrupts, which is INT0, that means interrupt 0, and INT1. These two are the external hardware interrupts. I hope you all now understand the basic idea about the interrupt and its type. Okay, thank you.